All right, guys. Moving on with linear algebra. Okay, one really important fact about lines is the notion of parallel and perpendicular lines, okay, and how their slopes sort of relate to each other. Okay, so if lines are parallel, they always have the same slope. Okay, that's what makes them parallel, having the same slope. And if lines are perpendicular, their slopes are opposite reciprocals of each other. Okay, so remember, not only do we have to take the reciprocal, but we have to change it to its opposite. Okay, so we're starting with a linear equation. This guy is in general form or standard form. It says find the equation of the line passing through this point that is parallel to it, and also the line that passes through that same point that is perpendicular to it. Okay, so the first thing we have to do is find the slope of this line. Okay, very first thing. So the easiest way to find the slope of that is to put it in slope-intercept form. Okay, so if we say, okay, let's put it in slope-intercept form, that means we have to isolate the y. Okay, so I would take this 3x and move it to the other side, so I get negative 10y equals negative 3x plus 5. Okay, so then we divide through by negative 10 all the way through. Okay, and so we get y equals, negative divided by negative is positive, so a positive 3/10 x, that being negative, minus 5 over 10 is 1/2. Okay, so this line right here and this line right here describe the exact same line. It's just that's in standard or general form, and this is in slope-intercept form. So remember, in slope-intercept form, the slope, okay, is the coefficient of x. So the slope of this line is 3/10. Okay? All right, so if we're looking at parallel, okay, parallel lines have the same slope. So if I'm looking for a line that's parallel to this, obviously it's parallel to that as well, okay, the slope has to be 3/10. And it says the line goes through this point, okay, negative 6, 2. Okay, now if I'm looking at perpendicular, okay, now remember, perpendicular lines have slopes that are opposite reciprocals of each other. So if the line is perpendicular to this line, its slope has to be the opposite reciprocal. Okay, so the opposite reciprocal of 3/10 is negative 10/3. But that line's still going through the same point. Okay, so we have to use the same point. Okay. All right, so let's see. It doesn't say anything about what form it wants our final equations to be in, so you could just choose. I'm going to just say, okay, I'm going to come up with both equations in slope-intercept form, but if you wanted to go to general form or standard form, that's okay as well. Okay, so let's see. That's not a y-intercept. Obviously, this isn't either. Okay, so I can't use y equals mx plus b, so I'm going to use my point slope formula. Y minus y sub 1 equals the slope times x minus x sub 1. Okay, so I get y minus 2 equals the slope, 3/10, times the quantity of x minus a negative 6, so that'd be x plus 6. Okay, so let's see, I get y minus 2 equals 3/10 x plus, let's see, that would be 18/10, so that goes down to what, 9/5, I think? Yeah, 9/5. Okay, so I add 2 to both sides, so y equals 3/10 x plus, let's see, if I add 2 to that, okay, that'd be plus 2 right here, okay, which would be the same as, what, 10/5? Okay, so 9/5 plus 10/5 is 19/5. Okay, and got what I need. Okay, so and that's in slope-intercept form. I'm just going to leave it that way. Okay, so we're good so far. So that's the line that's parallel to the given line and goes through that point. Okay, so let's see, I gotta do perpendicular now, so we know that our slope, okay, is the opposite reciprocal of the slope of the given line. Okay, again, I don't have a y-intercept, so I gotta go to my same formula. Okay, so I go y minus y sub 1, which is 2, equals the slope, negative 10 thirds, times the quantity of x minus x sub 1, so it'd be x minus negative 6, which is x plus 6. Okay, so let's see, I get y minus 2 equals negative 10 thirds x, and that would be minus, let's see, 3 goes to, what was that, minus 20? Okay. Yep. Okay, and then just add 2 to both sides. So I get y equals negative 10 thirds x minus 18. Okay. And I have the equation of a line that's perpendicular to the given line and goes through that point, negative 6, 2. Okay, we're good there. All right, let's try another one of those. Okay. Looks like it's the same type of problem. Okay, so once again, I've got to find the slope first. So let's take this guy and let's put it, obviously it's in standard or general form, so let's put it in slope-intercept form. So I got to isolate the y, so take that negative 2x, move it over. So I get 3y equals positive 2x plus 7, and then divide everything by 3, so I get y equals 2 thirds x plus 7 thirds. Okay, so we take a look here, and that's in slope-intercept form. So the slope of this line is 2 thirds. Okay, so let's see, we're going to do parallel. And obviously parallel lines have the same slope, so if I'm looking for the equation of the line that's parallel to this, it has to have slope 2 thirds. And it says it goes through this line, this point, 5, negative 1. And then I've got to do perpendicular. Okay, and if I'm looking for the equation of a line that's perpendicular to this line, its slope has to be the opposite reciprocal. Okay, so let's see, the opposite reciprocal of 2 thirds would be a negative 3 halves, but again, it's going through the same point. Okay, so 5, negative 1. Okay, it doesn't ask me specifically what form it wants the equations in, so once again, I'm going to go to slope-intercept form. All right, so let's see, I don't have a y-intercept, so I've got to go to my y minus y sub 1 equals the slope times the quantity of x minus x sub 1. Okay, so let's see, I get y minus negative 1, that's y plus 1, equals the slope, which is 2 thirds, times the quantity of x minus x sub 1, so it'd be x minus 5. Okay, so I get y plus 1 equals, let's see, that's going to be 2 thirds x minus 10 thirds, and then add 1 to both, subtract 1 from both sides. So we get y equals 2 thirds x. Let's see, I'd be subtracting 1, which is the same as subtracting 3 over 3. So negative 10 thirds minus 3 thirds, so that's going to give me a negative 13 thirds. Okay, and so I have my equation that is parallel to this and goes through this point. Okay. Now perpendicular. Once again, I don't have y-intercept, so I can't use y equals mx plus b. So we'll use our same formula. So y minus y sub 1, so it'll be y minus negative 1, that's y plus 1, equals the slope, negative 3 halves, times the quantity of x minus x sub 1, which is 5. Okay, so we have y plus 1 equals negative 3 halves x, and that would be plus 15 halves. Okay, then I subtract 1 from both sides, negative 3 halves x, and let's see, this would be minus 1. That's the same as minus 2 halves. Okay, so that's going to be plus 15 halves minus 2 halves would be 13 halves. Okay, and I've got my equation of the line that is perpendicular to the given line and goes through that point. So we're good. Okay. So far, so good. Let's see. They give us something. All right, now the important thing here is notice what it tells you. It tells you that you have a linear function. Okay, so we know ahead of time that this table describes a linear function. Okay, so this is your x column, so those are your x coordinates, and this is your f of x column, so these are your y coordinates. Okay, so these points would be 4, -5, -5, and -9.5. We've got a 3 and a -5.5, and we have a -1 and a -7.5. Okay, so let's see. And it wants me to write the equation in slope-intercept form and general form, okay? It wants both. And then it also wants me to identify the slope and the y-intercept. Okay, well, to be able to write an equation, I've got to calculate the slope to begin with. Okay, and notice we have a bunch of points on the line, so all you got to do is take any two of them to calculate the slope. And it doesn't matter which two you choose, it'll give you the same slope. It doesn't make any difference. Okay, so I'm certainly going to work with 4 and -5. There's no doubt about that because both coordinates are integers. And let's see. I think I will take, I don't know, I'm going to take this bottom one. I don't know, maybe because that's a -1. Who knows? And it's real small. So I'll work with that guy. Okay, so let's see. A -1 and a -7.5. Oh, a -7.5, not a -7.5. Okay, so let's see. I've got to find my slope. So again, remember it's delta y over delta x. Okay, so I am going to go these coordinates minus these coordinates. So I have a -7.5 minus a -5 all over a -1 minus 4. So let's see, that's the same as -7.5 plus 5. So that's a -2.5 over a -5. Okay, I'm pretty sure that reduces down to 1/2. Well, let's check it just to make sure. So use your calculator if you can't do it in your head. Let's see, 1 by 5. Yes, goes down to positive 1/2. Okay, so my slope is 1/2. Okay, so let's see. So my slope is 1/2. And obviously I need to use one of these 4 points. It doesn't matter which one you choose. No matter what you do, it'll give you the same exact answer. So obviously this guy is the easiest one to work with, so I'll work with this guy. Okay, and 4, -5. Okay, so it wants things in slope-intercept form and in general form. Okay, all right, so let's see. Y minus y sub 1 equals the slope times the quantity of x minus x sub 1. Okay, so I get y minus a -5, that's y plus 5, equals the slope, which is 1/2 times the quantity of x minus 4. Okay, so we get y plus 5, distributing 1/2, I get 1/2 x minus 2, and then subtract 5 from both sides. So we get y equals 1/2 x minus 7. And there's our SI form, so that's slope-intercept form. Okay, so I got that. Now I got to go to general form. Okay, so let's see. I've got to multiply everything by 2 to get rid of the fractions. Okay, so I get 2y equals 1x, or just x, minus 14. And move the 2y over. Or you know what, let's bring the x over this way. Okay, so I get a -x plus 2y equals -14. And there's my general or standard right there, okay? All right, so let's see. I have it in slope-intercept form here. I have it in general form here. Then it says identify the slope and y-intercept. Okay, so my slope and y-intercept, you could write y-intercept or b. It doesn't make any difference. Okay, remember. Okay, so we already know the slope is 1/2. Now the y-intercept, go to slope-intercept form. And so we have y equals mx plus b. So what's being added to x? -7, okay? And that's a point on the y-axis, so that'd be at 0, -7. And there's your slope and y-intercept. Okay, we're good there. Okay, let's see what we got going on in this one. Okay, so let's see. Are any pairs of lines either parallel or perpendicular? Okay, so let's see. Well, if we're going to figure out whether or not any pairs of lines are either parallel or perpendicular, we need to figure out what the slopes are to begin with. Okay, so let's see. This guy right here, y equals -6, that's a horizontal line. All horizontal lines have slope 0. Okay, so that's a slope of 0. Okay, this guy right here is in slope-intercept form because it's y equals, the y is isolated. So the slope has to be the coefficient of x, so the slope is 1/4. Okay. X equals 7, that's a vertical line. Okay, and we know that all vertical lines have a slope that does not exist. So that's D and E. Okay, so let's see again. This line right here is in slope-intercept form. I know that because the y is isolated, so it's like y equals mx plus b. So the slope here is -4. Okay, and then this last guy is not in slope-intercept form. So why don't we put it in slope-intercept form so that we can figure out what the slope is? Okay, so let's see. I need to isolate the y. So I start by taking the 2x and moving it over. I get -6y equals a -2x plus 9. And then divide through by 6, or I'm sorry, -6. So divide everything here by -6. So I get y equals, that would be a positive 1/3 x minus 3/2. Okay, so taking general form and putting in a slope-intercept form, and here's our slope, 1/3. Okay, so let's see. Why don't we start with parallel? Do we have any lines that are parallel to each other? Okay, so let's see. Slope of 0, slope of 1/4, slope that doesn't exist, slope of -4, and slope of 1/3. Okay, so remember, parallel lines have the same slope, so we don't have any lines that have the exact same slope. Okay, so there are no parallel lines. Okay, that's none. Okay, then we look at perpendicular. Okay, so remember, perpendicular lines have slopes that are opposite reciprocals of each other. Okay, so do we have any lines that have slopes that are opposite reciprocals of each other? Well, notice number 2 has a slope of 1/4, and the opposite reciprocal of 1/4 is -4. So number 2 and number 4 are perpendicular. Okay, so let's see, we would have y equals 1/4 x plus 3, and that would be perpendicular to y equals -4x minus 1. Okay. Now notice that we have a horizontal line here and a vertical line here. Okay. The reason this is D and E is because if you take the opposite reciprocal of 0, you get the opposite of 1/0, and 0 is down in the denominator, and obviously that's what makes it undefined. So any horizontal line along with any vertical line will always be perpendicular to each other. So we get y equals -6 paired up with x equals 7. Okay, a horizontal line and a vertical line are always perpendicular to each other. And that's all we got. Okay. Now it does ask, can you graph these lines? We can sketch them. Okay, it's not that big of a deal. Okay, we'll just work on the back of this paper. Can we sketch these guys? Okay, so let's see, and it's just a quick sketch, no big deal. You can use graph paper if you want to, you don't have to though. All right, so let's see, if we're gonna graph y equals -6, okay, so let's see, just take care of a quick sketch, no big deal. Well, that's a horizontal line that goes through -6. So if -6 is down here, okay, I would just get that line going right through there. Just a horizontal line, no big deal. So that's my y equals -6. Let's see, that takes care. You know what? I'll do number 3. Might as well do it on the same thing because I have one horizontal line, one vertical line. No big deal. So x equals 7, so that's a vertical line going through 7, okay, on the x-axis. So you would just have that guy right there. Okay, so that is your x equals 7. Okay, so that takes care of this guy and this guy. Okay, now when you are graphing lines that are neither vertical nor horizontal, I look at it this way. Okay, and again, these are just sketches. Okay, if I was in a coordinate system and I take a slope of 1, okay, so we look at some line that has a slope of 1. Okay, the easiest one to do is just y equals 1x or y equals x. So if I was graphing this guy right here, y equals x, that goes through the origin and has a slope of 1. Okay, so it's going to go right through here, and the fact that it has a slope of 1 means that I would have a 45-degree angle here and a 45-degree angle here. Okay, right there and right there. So anything that has a slope of -1, anything that has a slope less than 1, okay, and positive again, okay, would be shallower. So down here, I would have a slope less than 1. And up in here, I would have a slope greater than 1. Like that. And I always think of that in my head when I'm sketching lines, okay, because we don't need it to be exact, we just need it to be close. Okay, so let's see, I took care of these guys. Okay, so let's see what we have here. All right, now if we look right here, notice the slope is 1/4, okay, and clearly 1/4 is less than 1, so that guy's going to be shallower than this. So it's going to be kind of going down like that, assuming it went through the origin. Of course it doesn't. Okay, so let's take a look here. Okay, quick sketch, no big deal. And we are doing y equals 1/4 x plus 3. Okay, so first thing, it goes through, y-intercept is 3, so it goes through 3 on the y-axis. And its slope is 1/4, so it has to be shallower than y equal x. Okay, so rather than going up here, okay, where we would have a slope of 1, it's going to be shallower. So it might come down like this guy. Okay, and so that has roughly a slope of 1/4, and it goes through 3, okay, on the y-axis. Okay, and that's a decent sketch. It's nothing, doesn't have to be perfect. Okay, we don't need perfect. Okay, so let's see. How about we do this guy next? Okay, the reason I'm doing that guy after this guy is notice that both of them have a positive slope. Okay, so let's see. Quick sketch, no big deal. Doesn't have to be perfect. And we're doing this y equals 1/3 x minus 3/2. Okay, right there. Okay, so first things first, it goes through a negative 3/2, okay, on the y-axis, because that's a y-intercept. So let's suppose we'll put that guy right there, and that'll be a negative 3/2. Okay, now it has a slope of 1/3. Okay, so this would be a slope of 1 with the 45, 45, so it's going to be shallower than that. Okay, so rather than going here where I might have a slope of 1, it's going to be something like this. It's going to be shallower. Okay, so that would be a decent sketch. I know, it ain't perfect. That's okay though. All right, then last thing, I got to do that bottom one, and we have 2x minus 6y equals 9. Now, we put that in slope intercept. Oh, wait a minute. We already did that guy. No, I'm doing the negative 4x minus 1. Okay, forget this guy. Okay, so we have y equals negative 4x minus 1. Okay, got to do that guy. All right, now notice the slope is negative. All right, now we did this when you were in geometry. Okay, if we have a positive slope, it's an increasing line. It goes up from left to right. Okay, if we have a negative slope, it's a decreasing line, so it goes down from left to right. So we know this guy goes down from left to right. So you say to yourself here, well, wouldn't that be going down like this if I had y equals negative x, like that? Okay, so this would be a slope of negative 1. Okay, so over here, well, obviously that would be 45 degrees and 45 degrees. Okay, so up here we would have the absolute value, okay, of the slope would be less than 1, and down here we would have the absolute value of the slope would be greater than 1. So notice that this guy right here in absolute value is greater than 1, so that means this line with slope negative 4x will be kind of steep. It'd be going like this, okay, pretty steep. Okay, so let's see, it goes through negative 1 on the y-axis, and it has to be, that's, you know, with an absolute value of 4, that's a relatively steep line, okay? So it's going to look something like this. Okay, and that takes care of that. I always go back to this when I'm, you know, sketching lines. I mean, it doesn't have to be perfect, so that's something that always sticks in my head. Okay, so hopefully it helps you out, and I'll be seeing you this week in class.